Have you ever just looked up at the sky and asked one of those questions that seems so simple, but the answer is, well, it's way more interesting than you'd think? Today, we're tackling one of the biggest ones. We're going to find out what's really going on up there. I mean, it's one of the first big questions we ask as kids, right? And the easy answer is just, well, 'cause it is. But the real answer? Oh, it's this incredible dance of light and physics happening miles and miles above our heads. And then, just to mess with us, after a whole day of being blue, the sky completely changes its mind. It throws this spectacular show of reds and oranges. So how on earth is that connected to the daytime blue? All of this brings us to a much deeper question, really. Is that blue color actually in the sky? Or is it something else entirely? Maybe an illusion created by light, our atmosphere, and our own eyes? Well, that's the mystery we're going to solve today. So to start our investigation, we have to look at our main piece of evidence. And it's not actually the sky, it's the light itself, coming from about 93 million miles away. You know, when we see sunlight, it looks white, or maybe kind of yellowish. But that's just a clever disguise. It's not one color at all. It's actually all the colors of the rainbow, all mixed together into one. It's just like when you shine light through a prism, right? That white light goes in and boom, a whole rainbow comes out. Every single color we see in the sky is already hiding inside that one beam of sunlight. Okay, now here is the absolute key to this whole thing. Not all these colors travel the same way. Each one has a unique wavelength. Red light travels in these long, lazy, stretched out waves. But blue light, it's much more energetic, traveling in short, choppy waves. This difference is everything. All right, on to our second clue. That sunlight with all its different color waves doesn't just get a free pass down to Earth. No, first it has to survive our atmosphere, which is basically a giant cosmic obstacle course. So what's in this obstacle course? Well, it's not empty space up there. Our air is absolutely packed with trillions upon trillions of tiny particles, mostly molecules of nitrogen and oxygen gas, plus a little dust and water vapor. And this is where the action happens. When that beam of light smacks into one of these tiny particles, it gets knocked off its original path. It gets bounced off in a totally new direction. This whole process is called scattering. Okay, so we've got our clues. Clue 1, sunlight is made of different color waves. Clue 2, our atmosphere is full of tiny things for that light to bump into. Now let's put it all together and finally solve this thing. Now, this effect has a pretty fancy scientific name, Rayleigh scattering. But all that really means is that those tiny molecules in the air are way, way better at scattering short wavelengths than they are at scattering long ones. So, those short, choppy blue light waves get bounced all over the place, while the long, lazy red waves, they tend to just cruise right on by. Let's just walk through it. A sunbeam enters the atmosphere. Bam! It hits an air molecule. The longer red and yellow light mostly pushes right through. But that shorter blue light, it gets scattered like a pinball, up, down, left, right, in every direction imaginable. This means from where you're standing, it looks like blue light is coming at you from the entire sky above. And that's it. That is your blue sky. But hold on a second. I know what you're thinking. If shorter wavelengths scatter more, and violet has an even shorter wavelength than blue, then why isn't the sky violet? And you know what? That is an excellent question. It turns out there are two main reasons. First off, the cells in our eyes are just way more sensitive to blue light than they are to violet light. We're just biologically built to see blue better. And second, some of that violet light gets absorbed way high up in the atmosphere, so less of it even reaches us. So while there's plenty of violet light scattering around, our eyes are just screaming blue at our brains. Okay, now for the ultimate test of our theory. If we really get how scattering works, it should also be able to explain the beautiful mystery of the sunset. So the only thing that's different between midday and sunset is the angle. At noon, the sun is directly overhead, so its light takes the shortest possible path through the atmosphere to reach you. But at sunset, the sun is way down on the horizon, so its light has to travel through a much, much thicker slice of that atmosphere to get to your eyes. And what does that longer journey through the obstacle course mean? It means a lot more particles to collide with. On this super long trip at sunset, almost all of that shortwave blue light gets scattered away from our line of sight long before it can ever get to us. So with the blue light all scattered out of the way, what's left for us to see? Only the colors with the longest wavelengths, the survivors. The reds, the oranges, and the pinks are the only ones that can make that marathon journey all the way through the thick atmosphere to our eyes. It's the exact same science, just seen from a different angle.
And to prove this isn't just some special trick that only happens on Earth, we can look at our planetary neighbors, because the physics of light scattering, they're totally universal.
Ultimately, a planet's sky color is like a direct fingerprint of its atmosphere. You change the kinds of particles that are floating around in the air, and you completely change the color of the sky. I mean, just take Mars, for example. Its atmosphere is really thin, but it's filled with all this fine reddish dust. And those bigger dust particles are actually better at scattering red light. The result? The Martian sky often has this hazy, incredible reddish pink or butterscotch color. A different atmosphere creates a completely different sky. So in the end, you see, the color of our sky isn't a fixed thing. It's not a pigment or a dye painted up there. It's really the story of a journey. Light's epic, scattered journey through our atmosphere, all the way to you. A story that's always changing, depending on the time of day and even the planet you're standing on.